Okay, kids, so awesome. We're using the discussion thread. That is great. Chapter 1 assignment for 3U, question number 4. And it's about a boat moving about. So a fishing boat leaves port. So this is the port right here. So I'm going to mark this as initial position at 4:30 in the morning in search of some fish. It travels 4.5 kilometers east. Notice I'm using my G for given. I'm drawing a picture. There it is in the black line. 4.5 kilometers east. Then what? Travels 2.5 kilometers south. I kind of got it in this brown color here, brownish red. 2.5 kilometers south. Then what? Finally, 1.5 kilometers west. There it is. I've got it in green. Okay, and this is where it stops. So this is the final position. So I mark it right there. And from 4:30 to 6:30 means, oops, made a little boo-boo there. It's not 2 kilometers, it's 2 hours. There we go, much better. Okay, and they're asked to draw a scale diagram. That's what I've done here. 4.5 kilometers east, 2.5 kilometers south, 1.5 kilometers west. I guess to be really extra special, we should mark this direction as north so everyone knows our direction in our diagram. Probably should have done that. Then the other thing you need to remember though is what we want to find out through the complete diagram what its displacement is. Now I hope you remember the equation for displacement. Final position minus initial position, which is basically saying where are you now compared to where you are? What's the difference? Because another word for subtracting is difference. What's the difference between where you are now, here, to where you were, here? Well, I can show that with this blue arrow representing the vector displacement. I'm this far away from where I started, and I'm that far away in a particular direction I'm going to call theta. So I'm comparing where I am now to where I was. Difference, subtracting. But subtracting on a diagram can be shown like this. So this is where I am, this is where I was. I'm this far away at this particular angle. Now, in order to find how far this is, now remember the boat didn't actually travel here. The boat didn't travel here. All right. In order to find out how far this is, you're going to have to find how long this side of this irregular shape is. Right. But if you think about it, I can imagine a triangle in here. Right. I know this side because it matches the 2.5 kilometers. And I also know this side, the yellow part here, because I know the entire length is 4.5 kilometers, and I know this little bit I got to take away is 1.5 kilometers. So I know this side. All right. So here I've drawn the complete scale diagram. Now, R. I know some of you kids have been not wanting to use graphs. This is the way I solve problems. This is the way I expect you to solve problems. The first one required average speed, which is a scalar. Analysis. Average speed is the distance divided by time. It's the path length. You don't care about direction. How far did it actually move through the water? How far did it actually move? What's its path in the water? This goes back to our video lesson from a while ago, and there's examples in the textbook. And divide by how much time it took. As opposed to what's the average velocity, which is displacement over time. Even though the displacement here is not the path that it traveled, this is very much a mathematical idea, we're going to calculate it because it tells us what the difference is between where it started and where it ended and how much time it took for that distance to take place in the denominator. So in order to solve for this, you got to realize that displacement has two parts to it. The magnitude part. So you've got to find the length of this arrow representing the magnitude of the displacement. Can you do that? I hope so. You got a yellow triangle here that's a right angle triangle. You should be able to find a displacement, and you need to show me all your work. Also, displacement is a vector, so it needs to have a direction. Right? It needs to have a direction. So I need to find out what theta is. What is theta? And theta would be describing the direction in terms of east and south and things like that. So we have done something like this in our notes. Okay, we've done something like this in our notes. And there's also a sample problem on page 19 that could help you answer this to show you how to find this angle. All right, so there's sample problems on page 19 and 20 in the textbook. There's also the video lesson from section 1.3 that will show you how I solved a very similar problem. And that's the process you have to go through. All right, so thank you so much for asking this question. Really appreciate it. Have a great day. Bye-bye.